Now we're going to do a problem that includes both product of sums, sum of products, and don't cares. So we'll get a lot in this one. So first, we see that we've got three variables. So we'll draw a three-variable Karnaugh map. Those are some wonderful lines. So x1, x2, and x3. And then we'll label them the way we always do, 0, 0, 0, 1, 1, 1, 1, 0, and 0, 1. Now each of these squares corresponds to a min-term. So if you were to look at a min-term table, then you would see that, get here, oh, there we go. Okay, so if you look at a table here where you have x1, x2, x3 equal to 0, that corresponds to min-term 0. Where you have x1, x2, x3 equal to 1, that's min-term 7. So each square corresponds to a different min-term. Now, you can number them, you can write numbers in the boxes, and it's going to be the same ones every time, or you can just remember or look it up. So this is 0, 1, 2, 3. And then notice, because we put these in a kind of weird order, we're now going to jump over here and do 4, 5. Then we'll get back to 6, 7. So those are the min-terms corresponding to each square. Now, we have min-terms here, and we have 1s in 1, 4, and 7. So we'll put a 1 in 1, 4, and 7. And we have don't cares in 2 and 5. So I'll put a D here for both of those. Don't cares. Now don't cares are special because you do not have to cover them. So if you don't need it, you don't put it in there. But they can be either zeros or ones, whichever one helps you out the most. So, and I'm not putting in the zeros right now because I'm going to do the sum of products. So sum of products, we use the ones. So we want to find as big a group as possible and as few as possible that cover all of our ones. So I'm going to look at it, make sure I agree with what I did last time. Okay, we've got these 3 ones. Do we have a group of 4? Now remember, you can count the D's if you need to, but you don't have to. And no, we don't have a group of 4 even using the D's. So we're going to look for groups of 2. And we want to use as few groups as possible that get all the ones. So how can we get this one? We can get this one by using this D. So we can put those together. How can we get this one? We can use this one also by using this D. And how can we get this one? We can get this one by wrapping around to the other side and getting that D. So now for each group that I got, I want to figure out what do they have in common. So this vertical one here, they both have x1 equal to 1 and x2 equal to 0. This group right here, they both have x1 equal to 1, but the x2 is different, but they both have x3 equal to 1. And this last group, the one that wraps around, x1 is 1 here and 0 here, so they don't have that in common. It's 0 here and 0 here, so they do have that in common. So x2 bar because it's 0. And let's see, they also have x3 in common, and x3 is 1. Let's see if that agrees with my notes. And that agrees with my notes. So that is the product of sums. I'm sorry, sum of products. So now we're going to do product of sums. I could use the same Karnaugh map, but it would be kind of crowded, so I'll make a new one. Now, the zeros, you use zeros for product of sums, and you will have zeros everywhere that you didn't have a 1 or a D in this first one. So I'll put a 0 here, and a 0 here, and a 0 here. And now it'll have D's in the same places, because D's don't care, so they can be zeros or ones. So I'll put a D here, and I'll put a D here. Now, again, I'm going to want to cover the zeros with as big circles as I can and as few as I can. So groups of 4, no, there are no groups of 4 zeros. So starting with this 0 over here, what's the biggest group I can get? That'd be right here. What's the biggest group I can get with this 0? Right here. What's the biggest group I can get with this 0? And that's right here. Notice we don't care about this D and we don't care about this D up here because we didn't use them. So we don't have to use them. So now I'm going to look at this group right here. Now we're doing product of sums, and that's going to be the dual of the sum of products. So everything is going to seem kind of backwards. So in this case, wherever we have, thank you, Kitty. So wherever we have a 0, that's going to be non-complemented. Wherever we have a 1, that's going to be complemented. And we're going to have, up here we had products, here we're going to have sums. So let's look at this first group. Let's look at this first group right here. They both have x1 equal to 0. Okay, so that's going to be an x1 not complemented. x2 is different. They both have x3 equal to 0, so that's going to be not complemented, and it's going to be a sum. And we're making a product of sums. So now we'll look at this one, and we'll see that they both have x1 equal to 0, so that's x1 not complemented, and they both have x2 equal to 1, so that's x2 complemented. And then our last group is this green one right here. They both have x2 equal to 1, so that'll be x2 bar. And they both have x3 equal to 0, so that'll be x3. Okay, so you can pretend it says x3 because my computer's acting up right now. Okay, so there we go. So that's that one, and see if it goes with my notes. x2 bar, x3, x2 bar, x3, x1, x2 bar, x1, and x3. Now, if you look at the cost of these, if you assume that the complemented version doesn't cost any more than the regular version, then you'll see that this first one has 3 AND gates, 3 2-input AND gates, and 1 3-input OR gate. This one has 3 2-input OR gates and 1 3-input AND gate. So they're the same. That doesn't always happen, but sometimes it's useful to look at, you fill in all the ones, and you see that, okay, that looks like it's going to be like a lot of circles, and you say, well, if I put the 2s, I put the 0s, that's going to be fewer, then you might want to do that to get the best one.